So, welcome to week 3. I hope we are progressing in some sensible way. Last week towards the end we talked about the oscillations of the brain. So, it is like we have gone to the basics, micro, and then we are forming it and seeing how it works. Oscillation we talked about, and how the brain oscillations actually are used to carry information, modulate information, differentiate, integrate, and how a basic oscillation is going on over and which, depending on the activity which brain is doing and depending on the area, the frequency modulates, and when the brain synchronizes, it really goes into lower frequency. But how this whole idea of network, whole idea of how do this still it does not explain, in spite of knowing this oscillation. This is what we are seeing from outside by recordings and by modeling, but how are these networks connected? This was the big question towards the mid of last century, and the first answer which came from was not from neuroscientists, but it came from computer sciences actually. And this was the first model which actually came, what we call a McCulloch pitch neuron. The very simple thing, he used the logic of a computer and the logic of what you know as Boolean algebra, 0, 1 binary set of information which keeps the signal going. Like each signal can be represented in the form of binary signal. So, what he brought out, the McCulloch pit model, that and the idea was brilliant, because neurons, if you go back at the action potential, they do not fire till a threshold is crossed. So, from 70 millivolt, unless they come to minus 55 millivolt, they will not fire. So, for that to become a single neuron, a single input can never bring it to it. So, there have to be multiple inputs, and that is why 1000 to 10,000 neurons converge on one, in each one of them further, and this excitatory postsynaptic potential and inhibitory postsynaptic potential, they unite to bring it to a threshold. This idea was, I mean, they brilliantly caught it actually. They said it is a real neuron model is a threshold, it is a threshold logic unit. That means, unless the whole input goes to a threshold, there will be no further output. So, the idea was that a set of connections brings in activation from other neurons, right. This is a neuron 1, 2, 3, 4, and then a processing unit processes it and then puts a output which goes to other neurons. So, what they said, that this is the whole thing, this process of input and processing the information is like that each of them have a weight, and the summation of these weights decides what is going to be the output, and it is a non-linear thing. It is not a one comes and one will go out, two come and two will go out, it is not like that. So, this whole summation process is a non-linear process, which they call squashing, transfer or threshold function. This was the first model, and it became very popular, but there was an issue with it, and the issue was that the brain does not function in the binary way. It may at a level of single neuron, but the question is that the output is very complex. Output is, so although this process of the whole thing of summation could have been non-linear, but the output by these neurons have to be a linear thing. But brain does not work like this. The layer of complexity, the behavior, the type of processing does not fit in. Plus also, but this was the beginning of whole, not the beginning I should say, but It is a big impetus to what the whole computer artificial intelligence thing got. You can train the neurons by putting in different weightages. But these brain also remembers, brain is plastic, it modifies. These neurons did not have that capability, this model, because if certain inputs come, they apply, go, how is it going to modify? This is not explained. So, another idea which came was perceptron. So, perceptron was a very popular thing, but and that was a big fillip to the artificial intelligence, but it had its own criticism, because obviously brain I am sure does not follow one simple physics which. So, but following this was happening around Second World War. What came out was a Hopfield brought out. The Hopfield model is interesting, and Hopfield actually brought the whole idea not from neurons, but he was thinking about magnetism. And the best I mean what actually was his big question was that in a magnetic field, there is a memory. There is a memory of the, how does it happen? Possibly in a magnetic element, which have, if they are saturated, obviously there cannot be a current flow and there cannot be magnetism. So, these magnetic elements have free floating electrons and their spin. So, within a magnetic material, there may be pockets where all the things are aligned in same way, and they continue to remain in the same way, because that is their memory. Soft magnetism we know has a memory. So, he brought out the idea that the same thing may be happening with neurons, that it is the same set of neurons, maybe differently in different pockets, which align together in their activity. He took out a model from already published paper by Hebb, we will talk about Hebbian thing, and he brought out the idea of associative learning. Now, if you see this, just a simple thing, these are neurons, these are the layers, if you remember, 1, 2, 3, 4, B, 5, 6, these are pyramidal cells, and this is the, so layer 5 is this, which is pyramids, pyramidal cells which fire. Layer 4 where there is a lot of input, and layer 2, 3. From pyramids, this is the type of cells which exist, and this is the type of network which they form. So, blue will go to blue, red will go to red, and this is going to all the cell groups. So, there are single cell layer, then there are multiple type of cells. These multiple type of cells form another network amongst themselves as they grow higher, and the single cells give connection to everything. This is the type of associative network, and is a asynchronous parallel processing. There can be a random parallel processing, synchronous parallel processing, they can be random, fully interconnected. Now, there is a good example which is given in one of the books called Demystifying Brain by I think Mr. Chakravarti, which is there available on the NPTEL site. This is one of the best thing. The basic thing is, it is a content addressable memory. What is a content addressable memory? Suppose I have to tell you, for example, take rows. Now, if it has been a very linear type of stuff, then first if I tell you about rows, then first you will have to remember ROSE. Then you will have to look at the shape, maybe then the colors of the petals, then the feeling of thorn pricking or smell. So, the time is a problem, brain does not do it like this. So, Hopfield brought out this idea that even if a noisy or incomplete version of the pattern stored in the brain is given, still the whole memory can be activated. You try this. If I ask you to just think of rows, you see how many things come into your mind. Even if I give you a plastic rose, even then the memory of rose can come. if you tell a child R, A for apple, A for apple, so it is just A, but everybody knows A for apple or R for rose. So, it means instead of storing memory part by part, what you do is you have associative memory. So, any stimulus here or here or here can retrieve the whole pattern. This was Hopfield's model. It was what he said, that all this, once some stimulus goes in and brain tries to remember all that and brain tries to form associations, in the process of learning there may be high energy maxima, but ultimately when the memory is settled, there is something called a minima, a local minima, where the energy level of this whole thing settles down. So, he was actually using McCulloch-Pitts formula of weighted stimulus coming in, right. Then this gets into process. The association is the most important thing. So, this design a network based on energy function. So, he introduced the topic of the concept of recurrency. He said, if this networks are associated with each other and connected to each other, it is not just once that the thing goes and settles down. It is a lot of feedback loops. It keeps firing recurrently till it reaches as a result of recurrency, the network total energy decreases and tends to minimum, which is the attractor stage, which is a term from nonlinear dynamics. You know, attractor stage where symptoms can naturally tend to go and settle down. So, he said this local minima of energy is the attractor, and that is where memory is formed. This can happen in synchronous way or a asynchronous way. There is a very famous travelling salesman problem, you can always read that if a salesman has to find, does he go door to door to find somebody, because that is the process, but brain does not work this way. So, essentially a travelling salesman can find out a network which. So, memories are represented as attractors, they are a stable state of network dynamics. What is an attractor? It is an internal representation of a stimulus in the form of network. So, anything which goes on into your mind has to be there to be represented, to be, and why, if you remember now. I told you that if anything comes to you, first the basic systems of the brain will evaluate on the hierarchy of survival threat. And that is why we require so many neurons, and that is why we require the network and synaptic strength of so many neurons, because of a simple reason, that all this information and things which are going on into your head, your mind should know it, because what will maximum things, or what will bring in the threat, what will bring in a survival problem, we really do not know at this point. So, that is the basic attractor where representation of that memory is stabilized at a basic energy level. The changes in attractors are the synaptic modification. So, how does it do that? Attractor state essentially means that between those neurons, they must be existing in a certain stage of synaptic connections. We stimulate them with a fresh thing, repeatedly they keep firing, the synaptic shape changes. It may be a temporal change or a spatial change, because if it changes, that change is preserved. So, next time when the stimulus is gone in, so that is now you understand there is something called a immediate memory, short term memory, long term memory. Immediate is something is presented to you, your brain recognizes it. If it has already seen, if it has not seen, it will try to remember it. In the short term memory, this recurrent firing will keep happening in associative form. Lot of neurons in a network will get associated to take all the feature extraction of that stimulus. So, that everything of that thing possibly goes in, whatever gaps are, brain will put it back from the Gestalt memory and all. If you remember, I talked about Gestalt. This changes the whole synaptic geometry. Once the synaptic geometry changes after few minutes or whatever, by rehearsal, by training, by repeated stimuli of the, every time a dog comes and bites you, that will go into your long term memory, or the dog bites you so severely in the first time, it will alter the already existing synapses. So, that may become permanent, goes to long changes. So, what happens? Every time this stimulus is presented, the recall will happen from this long term memory, because it is already stored there. So, the brain, that network has to just recognize one part of, even if it is a noisy stimulus, even if it is incomplete, the brain will recognize it and it will start moving. This was actually based on Donald Hebb's work. Donald Hebb simply, I am saying it simply, but it was tough for him to think. He said neurons that fire together, they wire together. That means the first stimulus, first time a stimulus goes, this is activated and the neuron in the neighborhood is also activated. Okay. Every time you keep firing, this network will get strengthened. So, every time the presynaptic neuron and the postsynaptic neurons are fired together, their synaptic strength will keep increasing and they will always fire together. That is the basis of short term memory. So, there is a Hebbian way of learning, which is the most common. The links between neurons are strengthened and they have a distinctive firing pattern. Okay. So, every time this comes, they will together. So, once this is a short term memory, this fires, again this fires, this fires. This is very strong. Now, every time this will fire, this will fire. So, memory will consolidate and then synaptic changes happen, as I told you in Hopfield Model, that leads to long term memory. This happens in an area called hippocampus. Hippocampus is a deep area within the temporal lobe, and in the short term there is something called a Pepet circuit, which we will talk about. The whole thing is transferred from hippocampus. Once these neurons have established a connection to a widespread area in the brain. So, there is no definite area in the brain which you can say that okay, memory is stored here. Memories are widespread, otherwise you know what will happen. The brain will be oversaturated. Like you have 1,000 neuron for rose, 1,000 for thorn, 1,000 for color, 1,000 for, it can't happen. So, smell has to come out from the smell area, vision has to come out from it. So, it is a widespread long term memory which is spread associative again. So, there may be 1,000 centers which will get activated when you think of rose, maybe your memory with your spouse and your lover, but that will be in a different area. The hippocampus is largely involved, and that is the area which gets first damage when people start losing memory in an illness called dementia. Alzheimer's dementia, the first sign of Alzheimer's dementia is a recent memory deficit. And if a lot of people who come to us, they will say purani baatein, they remember old thing, they do not remember the new thing, because the hippocampus is the place where the maximum damage is happening. So, this whole Hebbian learning is gone there, the network gets damaged. I also told you that even if a noisy stimulus goes, the brain will still form a image. That is the Gestalt psychology. The Gestalt people tell you, if you read them, That brain uses lot of smart tricks like closure, like approximation, like proximity to complete the image, because brain does not want uncertainty, and brain, a human brain or any brain for the matter, does not like ambiguity. So, if you give ambiguous signal, the brain will always try to form a certain thing. If you look at clouds, you will always see some images there. Lot of people see it. In the smoke patterns, you can see images. People see images wherever there is no image. So, that is the thing. So, is it a marriage of Hebbian neurophysiology with Gestalt psychology? Cell assemblies. So, what was Hebb saying? Hebb was saying neurons which fire together, and so these neurons amidst this huge network, and what they form, this columns and all, there are functional cell assemblies. So, it is not one to one neuron which is firing together. For every stimulus and its memory, there are cell assemblies which will fire, which will try to create the full impression of the external thing, or maybe internal stimulus. You can close your eyes and you can think about your last meal. You may still get the smell, taste, whatever. So, that is the memory which has gone in, but all cell assemblies which were firing together at that time when you were eating that sumptuous meal will be firing in reminding you things. Now, in recall, it may not be necessary that all the presynaptic and postsynaptic will fire together. In recall, there is a copy of it in a different area. So, then recall only part of it may do, but while it is forming, the cell assemblies will go together, and rest of the information which does not go is already done by. So, they are embedded in global synaptic action field. Why global? Because there are no set places for memory, there are no boxes like computer address, they are all content addressable. Content addressable means any part of that whole memory can trigger off the whole memory. So, they have to be widespread. So, also when I am saying it that presynaptic, postsynaptic, it does not mean they have to be in close vicinity. There may be 10 neurons which may be firing together to bring out one memory, and they can be widely separated. So, once cell assemblies are widely separated, this whole thing becomes global. If they are in close vicinity, is local. So, they are embedded in this. So, it is like a social networks embedded in culture. We all live in India, we all are Indians, we have a common culture with minor variation here and there, but my social network may vary from my apartment to my friends, Indian friends living in New York or Bangalore or Calcutta or. So, we are say a Hebbian cell assembly, we know each other, and if a problem happens to me, all my friends will get activated. All the time they do not have to keep firing or being activated and know every minute of me, but there must have been a point of time when we were firing together. Otherwise, how would I form a network with somebody who is living in Australia? So, there must have been a 6 months period where we were doing everything together. That established the memory, and now if something happens to me, then the whole thing will get activated, just as a survival mechanism maybe, just as it is. So, this is, we are embedded in the culture, but our social network goes from this point to whatever space time geometry we are talking about, and these global fields have a top down and bottom up. So, things can come from top, they can go from down. So, this is a broad way of looking at. So, if you have to look at the summary, they are nested hierarchical interaction across spatial scale, as I said, non-local, resonant interaction. Resonant means keeps going, and some of them may amplify and is a binding. So, consciousness may critically dependent on this phenomena, which is not our concern at this point of time. we will talk about it as and when we, right. So, I will wrap up this lecture here with this image. We have talked about networks and oscillation, and you have seen Hopfield and the way things form. We will come to memory again. What is this? This is, you must have been knowing this. There is a film also, very famous film, Babel. This is a mythological story. When God made human beings and the various species, and it is said probably they were troubling him too much. So, he also knew he is a smart, because he is God. So, he created this Tower of Babel, and on each floor of it there were inhabitants. So, together he knew that they can create a lot of chaos in life. So, he did a smart thing, and his smart thing is they all had different language. So, one floor could not communicate to the other. So, this is a Tower of Babel. Brain also, if you look at it, everything appears different. Behavior, a huge behavior, people right from love to killing, they do lot of things. You come down, where is it arising from? They do differently, they act differently as individuals. In small groups they act differently, in large groups they act differently, country they behave differently, continents they behave differently, but baseline behavior, everything is coming from the brain. Come down, you have cerebral hemisphere, you will see nothing. You open up a live brain, you do not know what to do with it. On naked eye, you really do not know what is happening. Then we have got technology, you start looking at the electrical waves, or you cut a dead brain and you find lot of, grossly you see chunks of these pieces, then you go over microscope, you find neurons, huge number of neurons. You sit with all that, what do you do with that? Structure. So, structure does not mean anything to you. So, you go further device ways to look into the activity. You find EEG waves, but now you have MRI, you see some brain area highlighting, all that is direct, indirect signals, again of no meaning. Then you go further, bring out mathematical models, look at the guess of whether these neurons are connecting this way, which partially are proven with psychology, partially unproven, because you give task, you ask people to perform, you guess okay this network is functioning, but still to really differentiate between these networks, these are, you really can't verify it, but because it fits into your theory, that is why it sounds sensible. And this networks keep firing with oscillations, electrical activity which you have picked up on EEG, and how do they but still we do not know how do they really translate into behavior. They may be firing, what does it mean? Physically, yes, maybe, but maybe you move your hand, you can see it on MRI or EEG, or you can put it to the computer, do it. But beyond physicality, how does it think? How does it emote? These are big questions, because how does this electrical activity actually changes to thought, action, me? We will talk about it in the next lecture. Thank you.